Good evening, everyone. We're looking to see if we are going live now. Looks like we're good on YouTube and we're good on Instagram and we're going live on Facebook and everywhere else. So good. We're live and we're ready to roll. Let's see here. We have a lot to talk about tonight, so I want to make sure everything is working properly. And it looks like it is, and we are on YouTube as well. We already have questions coming in. Wow, love that. So, let's talk about a lot of things going on right now. We're going to dive right into it because we actually have tornadoes that have developed in Maryland to the south of us. And I want to break down the factors that are supporting that and also what impacts do we have to watch out for as this heavy rain and embedded thunderstorms head towards our neck of the woods. So let's dive into the data. And then, of course, as always, I'll come back to all your answering all your questions and going over everything else that is going on in the world of weather. I'm sure I'll get plenty of interesting questions. Now, currently, we have a warm front that's approaching a region. Typically, when you have a warm front lifting through, on the south side of that warm front, you start to get the potential for some tornadoes. Sometimes that also happens right on the leading edge, but many times it happens just south of the warm front passage. And that's essentially what we have been seeing, especially in portions of Maryland this evening. While that is happening, you can see the southeasterly winds here at the surface over the northern mid-Atlantic. Why am I pointing this out? Very important. The source region of air masses is extremely key when you're forecasting for mesoscale forecasts, for mesoscale events. The southeasterly wind is coming off the Atlantic. If we were in the plains, it wouldn't matter, okay? Because that southeasterly wind would enhance the vertical wind shear in the atmosphere, but it wouldn't be transporting any air masses directly off the cooler, more stable Atlantic Ocean. Since we are transporting that more stable air mass, it's going to become a more significant factor in our forecast. For our forecast, for our region, when you're looking for tornadic activity, you typically want to look right in here. Now, you can get them as far east as portions of the Monmouth County coast, and heck, you can even pop them up in Long Island. But usually those are very, very fine cases, very difficult to evolve and set up, but it can happen. But that southeasterly wind normally sets up a more stable environment here, and you have more of your instability right here because the southeasterly wind and the air mass is developing out here is slightly more unstable. Now, typically, we have a very warm, unstable environment, one that would feature a lot of thunderstorms. This time, we're not seeing that. Instability is more in pockets, and the environment to support these thunderstorms are more in pockets. So, when you look at the latest information, this is our WeatherTap radar. Okay, we could see our stationary front / warm front down here to the south. Here is where we're seeing our tornadoes, and we'll dive into that in just a moment. All this featured severe thunderstorms and tornadoes earlier when it was down here, but since then it's transferred over into heavy rainfall because the environment is more stable in this area. But in the meantime, we're seeing just enough turning in the atmosphere to support some pretty dynamic tornadoes. Now, here is the latest observations that are coming in. This storm is especially being focused on. This storm earlier produced tornadoes, but now it has started to lose that vorticity, that turning in the atmosphere as it's moving into a more stable environment. Let's dive into the winds here. Now, this is a very fun piece of information. If you're not used to this, basically what you have here are the winds moving away and towards a location. Red usually is away, green is usually towards. And what you want to do when you're looking at this environment is looking for clashes. As someone who's colorblind, this is always very fun to try to study because you might see green and red, but I see gray and red. So when you're studying this, what you want to look for is basically lesser words, Christmas colors. So let me zoom in here. Let's see here, controls. We'll zoom in a little bit. That signal right here, okay? What this is basically showing is circulation in the atmosphere. All right, so think about it. Winds are moving towards and away in the same location in a small place. What type of setup causes that? Well, a circulation. So National Weather Service meteorologists, what they do is that they look for these couplets. Now, sometimes they form on the radar in the mid-levels of the atmosphere and the lower portion of the thunderstorm cumulus cloud, but they don't always reach the ground, which is why we need people like storm chasers, responsible ones, of course, that go out there and say, hey, look, I see the observation. Here's the damage. Here's the video of the actual tornado touching on the ground. So those people help out significantly in these type of events. I've been noticing on X some great features, some great videos of those tornadoes that have been forming in this area. One in particular right around here. Don't know the strength yet. We usually can't really determine that until after the tornado moves through and then we start to analyze everything. But they certainly are well developed, so I wouldn't be surprised if you have an F1, I wouldn't be surprised if you get that type of record. Now, we just got the update, right? Notice what just happened. The couplet here is starting to weaken, much like what we saw as the other storm was heading up towards Washington, D.C. and Baltimore. That second storm, it's lost its rotational couplet because the vertical wind shear is not as strong. So why is that? Well, let's take a look at some of the factors here that are going into this event. First of all, your precipitable water values are through the roof, okay? One of the things that I've been noticing and that I have been drumming home relentlessly is the high amount of moisture in the atmosphere, which we measure as precipitable water value, has been going through the roof over the past decade and a half. And when you have more moisture in the atmosphere, when you have more buoyancy in the atmosphere, you have the potential for us to amplify thunderstorms. Now, it does not lose my attention that these thunderstorms and this environment is occurring once again on the northwest side of the urban heat island in the I-95 corridor. Remember around Philadelphia, where did we get all of our thunderstorms set up where they became severe? Right on the I-95. It looks like we're getting new data coming in, but that's okay. Right around the I-95 corridor is where we saw a lot of our severe thunderstorms and tornadoes. And here it just came in with new data. It's perfect. So again, you have your I-95 corridor here, and I have been hypothesizing that these thunderstorms are being enhanced by that urban heat island effect. Not the specific heat center, but by the gradient itself, because you're leading to more microscale and mesoscale lifting in the atmosphere because of that gradient. And I think that, and it doesn't need like a huge gradient here. All you need is about a half a degree Celsius, and you get enough gradient in the microscale and the mesoscale, the small scales, to set up that lifting and enhancement of lifting and that turning motion in the atmosphere. So we're seeing that. And then let's take a look where we have our best bulk shear. Well, pretty much right where we're seeing our tornadoes. Again, you're seeing your strongest lifting here. Notice around the northern mid-Atlantic, nothing, nada. This is right along the warm front here. The warm front's lifting northward. While this whole couplet lifts northward, what we should see is a continuation of a weakening of this environment in terms of bulk shear while we continue on with our deep moisture. And you can see the moisture transport is driving right into our region. So when I combine these factors together, it's no surprise that we're seeing the severe thunderstorms that we're seeing now. I would not be surprised as this rainfall and these thunderstorms move northward, that we don't necessarily get a tornado, but I would not be surprised if we get a strong mesoscale low within some of these thunderstorms because of the turning motion. I wouldn't even be surprised if there's a tornado warning that pops up overnight, let's say around central New Jersey, southwestern New Jersey, as this is lifting northward because of the turning motion in the atmosphere and the elevated thunderstorms that are going to be moving through. So what does that look like? Well, this is the HRR that just got updated. Let's see if we got a new one that showed up yet. And perfect. Okay, this one's brand new. So let's pull this up. So here you have your storms coming up in this environment, and let's see what this looks like. Requesting the sounding. Perfect. Okay. So the first thing I noticed with these thunderstorms is that, you got some low-level vertical wind shear. And we know that directionally because we have winds coming in from the south at the surface and the southwest everywhere else. So not incredibly strong, not impressive, but enough to cause enough of a twist in the atmosphere. Cape values, not really all that impressive. That kind of tells you that you have a relatively stable yet moisture-loaded environment. Let's see, what else? Your SRH isn't all that impressive. 399 meters squared per second is not off the charts, but certainly a strong signal for very heavy rainfall. The winds here, normally you hear me talk about downburst wind gusts. And when I talk about that, what I normally am looking for are 40 or 50 knot winds around this area here. Not really seeing that. So this looks like pretty much a heavy rainfall event lifting up towards our area. And that shows up pretty nicely here on the HRR from weathermodels.com. You can see that heavy rainfall moving through. So it's a cluster like this, where I wouldn't be surprised if it gets warned as a severe thunderstorm or as a potential tornado warning. Because of the turning nature in the atmosphere as this warm front is lifting northward, that combination is going to lead to that potential for turning on the radar, but not necessarily the observations at the surface. So definitely watch out for that. Very impressive heavy rainfall setting up out of this. As far as lifting involved in this situation, frontogenesis is not really all that impressive. It's pretty weak at the surface. Not really seeing much at the mid-levels. So what's causing all this lifting? Well, let's take a look at divergence. And this is how you get your lifting. We're having a rather unique setup in this whole storm event, where the divergence aloft is enhancing the rising motion in the atmosphere. And what we're looking at, again, this is from spc.noaa.gov, so totally free. Well, kind of free. You pay for it with your taxes. This signal right here tells me that at the higher levels of the atmosphere, you're getting stretching occurring. And that stretching that's occurring is helping to enhance the lifting at the mid-levels in the surface. But it's not necessarily frontogenesis because, well, quite frankly, the temperatures here aren't exactly all that much different. This is all driven by a moisture gradient and divergence aloft. And that shows up pretty nicely here on our satellite pictures. You can see the strong lifting here, right where we had that divergence and diffluence. Take a look at another feature. This is the infrared satellite picture zoomed out. And you see this feature out here? Let's pull up the water vapor. This feature right here, what's happening is that this is an upper level trough over the northern plains that's tilting into a negative tilt, trying to stretch and cut under the ridge and this feature up here. So the combination of these two is leading to that divergence and diffluence. Now let's take a look and see what that looks like in the upper level winds here. And we'll put up HD to get a little bit better data. And look at this setup here. This is usually something pretty unique here. You have your ridge axis to the north. This trough is trying to undercut this ridge in the polar jet stream that is split around this upper level low here. The spreading out in this area here is that diffluence we were talking about. So you're stretching the atmosphere like taffy. So you're having this rapidly rising motion in the atmosphere at 250 millibars. In order for the atmosphere to bounce that out, that has to extend down to the surface. So that's why you're seeing this interaction with this warm front and all that heavy precipitation. That combination with the slight turn in the atmosphere at the lower levels of the atmosphere is what is setting up the development of our thunderstorms with tornadoes. So you see how I came back and circled all that together? All of this is evolving because our pattern that we've been talking about for the past 3-4 weeks of changing is happening right before our eyes. And over the next 10 days, we're at June 5th right now. I said by around June 15th, we'd start to see more of a La Nina influence with a strong ridge off the East Coast and that Bermuda high setup. That's all starting to evolve. In order to get there, this process has to work itself through. And so that's what we're seeing right now. The polar jet stream is becoming stronger under the La Nina influence. Subtropical jet stream, it's weakening, and its influence on our weather patterns becoming less and less. It's typical of a La Nina. Combine that with the negative PDO, which is going to displace this ridge and allow for this trough to extend. It all sets up the environment where we shift from this active weather pattern that we've been dealing with throughout the spring with pesky showers and cool conditions to one where it ends up being a bit more tropical. But before we get there, we're going to deal with these heavy rainfall events and this unsettled weather pattern. So while that is all evolving, again, you can see the changes here in these thunderstorms that are developing here. We just got new data in. There's our couplet trying to hold itself together. This storm is probably going to continue to mean business until it gets to about the suburbs of Baltimore, and then it should start to weaken. But unfortunately, everyone in this area and locations like around Columbia, unfortunately, it's going to be a very, very stormy evening until this thunderstorm completely weakens. And take a look at the trends here with the thunderstorms. This one back here was the original one that started producing tornadoes. Look how it weakened. Here, let's zoom out a little bit. You can see how much it has weakened since then. This one also, and it has lost its couplet and started to weaken. Why is it doing that? Because it's all moving into a more stable environment. And so that's essentially what we have been watching. Going forward, what to expect? Well, there's our trough trying to build in, like I was describing. Through this weekend, it's going to remain pretty unstable. We have cooler air. I wouldn't call this colder air. It's a polar Pacific type air mass. It's going to keep us pretty unsettled. I know there's a couple of people that have plans. I've already gotten emails about plans for this weekend. Usually it's wedding season too. This is not a washout type weekend, but it is certainly one that could feature a few pop-up showers in the afternoon, especially when we maximize our instability. Not looking at any type of significant storms or anything of that nature. There was some guidance, this morning, in fact, we were talking about it in the video, of a low pressure system trying to form out here. I suspected it was too strong on the operational, and it has trended in that way based on what we're seeing here. Not really all that impressive now. Why? Because the operational was creating too strong of a trough in this environment, where the ensembles was much weaker and the AI ensembles was actually much weaker as well. And the reason why we know that is look at everything off to the west. Everything else is very, very fast, very progressive. So when you have this type of setup to the west in the spring, summer, fall, or winter, whenever you see this signal, anything on the East Coast is going to get kicked out to the east and generally weaker. So I typically don't buy, or typically doesn't work out to have major storms in that type of environment, which is why I ignored it and kept on with the isolated showers in the morning on Wednesday. So that's working out pretty nicely. So the weekend overall, not too bad, just a few isolated showers. The severe weather is pretty much going to be remain focused over the southern mid-Atlantic. Now for tonight, I would not be surprised if we get some very heavy rainfall and some flash flooding around, let's say, the I-95 corridor right in this area. There is some focus here around Newark. It might be a real pain in the neck for flights to get out early flights. The first flights in the morning might be delayed by this heavy rainfall. Then we have another round of potential thunderstorms trying to pop up in the afternoon with the cold front. There is some instability in the atmosphere, especially if we get enough clearing in time. So that could lead to a few pop-up thunderstorms for tomorrow afternoon. But I'm not expecting anything that would feature severe weather outside maybe a lone thunderstorm with some powerful downburst wind gusts. Meanwhile, the tropics remains quiet. So that's certainly the best news of the night, right? Where we have no threat whatsoever of any type of tropical development. No sign of anything, at least over the next 7 days. I would start looking out for the coastal waters of the southeast and the Gulf of Mexico after June 15th. We'll keep an eye on that and see how that plays out. With that, I am going to start taking all your questions, and we'll start off with the premium section, and then we'll drop into YouTube, and then we'll see what else we got thereafter. Okay. Okay, so Andrew Madden asks, what would need to happen, understanding it's not this year, to have summer weather like this past Friday and Saturday for the majority of it? Let's see here. What was Friday and Saturday? Friday was relatively nice out, right? Saturday was nice, sunny. It's been crazy, so I got to go back to my days. Okay, so generally temperatures in the 80s. It was nice, sunny. What you want is a strong Western Atlantic ridge to build into the East Coast. You're going to still have humid conditions. Look, when you're in July and August, anytime you have plenty of sunny skies and it's going to be in the 80s, it's pretty difficult to get that type of weather setup with low humidity. It's very difficult. But the best way to do it is have a Western Atlantic ridge build into the southeast coast, then a cold front passage drops through, and then you clear out the humidity for a day or two. But eventually you will see that rebound. I would not be surprised if we see a few days like that this summer. We'll have to pay for it with severe weather. Very robust thunderstorms. But I think that the overall theme is with that Bermuda High and the Western Atlantic Ridge building in. You're going to have some days where it's going to be nice and sunny, but a bit humid. Any sign that even with La Nina conditions, the subtropical jet may retain more strength than it typically would, not to the extent of last La Nina, but still more than normal. There is research going on, and a paper recently came out about the influences that the volcano from a couple of years ago that put all of the water vapor, Tunga, okay, what's the name, that has influenced the way that the atmosphere is evolving in the northern hemisphere, specifically when it comes to what we normally would expect with El Niños and La Niñas. So, with this La Nina, by the way, the idea that this is going to be a super strong La Nina is dead in the water, okay? I never bought that to begin with, but it is clear, very clear, that this is going to be a weak, maybe a moderate La Nina. So what that would typically suggest is that your subtropical jet stream isn't completely dead. It's not as robust, but watch out for convection around the date line. That could be a signal that we're going to be dealing with more robust and more active subtropical jet stream than you normally would. There's a bit of a warning sign in that, though, okay? If you have a more active subtropical jet stream, let's say slightly more, right? And it sends some disturbances through the southern tier, and you have a strong Western Atlantic ridge, that can set up the environment where you have below normal heights or at least a weakness around the Tennessee River Valley. And for the southeast coast and the mid-Atlantic, you really don't want that if you have any type of tropical system off of the southeast coast or around the Bahamas, because that alters the steering currents and is more likely to take any tropical system towards the coast rather than away from the coast. So that would certainly be something that I would be very concerned about. But again, that when and if that event actually happens, we have to dive into the finer details. Orientation matters, strength matters, blah blah blah. You get the idea. But that type of environment would certainly be something I'd be keeping an eye on. Presumed stable marine air will prevent tornadoes in our area tonight and tomorrow. For the most part, yes. Like I said, some of these thunderstorms that are lifting northward, especially the ones just passing Baltimore, they could hold on a little bit more as the warm front is pushing northward through southern New Jersey and towards central New Jersey and southeastern Pennsylvania. We can't leave them out either. And that could be just enough instability to keep those thunderstorms rotating a little bit. I do not expect the same type of environment that we're seeing down in Maryland. What I would expect is maybe the radar would show a little bit of turning. They warn it, but nothing actually reaches the ground because, again, that more stable environment. But you'll know that this mesoscale low has developed because the rainfall will be very heavy. When you have a mesoscale low in a thunderstorm, you're enhancing the turning at the medium small level. Okay, so let's say at the size of New Jersey. Okay, within that storm, that's the type of scale that we're talking about here within the county, right? So while that turning is occurring, and we get down to the microscale of the thunderstorm, that turning in the thunderstorm enhances the rising motion, which enhances the precipitable water rate, enhances the rainfall rates, enhances the potential for mixing, and enhances the potential for things like hail and, yes, possibly a tornado. So the mesoscale low itself, I think, is going to help to enhance the heavy rainfall tonight. So I think that's more of a concern than anything else. Card is asking, once again, Nature magazine just had a piece that dropped in sulfur dioxide emissions in the past decade, particularly the large drop due to changes in shipping has increased temperatures by allowing solar heating of oceans. Yeah, this is very interesting, okay? Pollution doesn't go just one way, in terms of impacting the atmosphere. You can cool the atmosphere with some releases of gases, and one of those would be sulfur dioxide. Now, sulfur dioxide itself, well, it's not something you actually want to breathe in, trust me. So there were an international law or rule to reduce and ban the sulfur dioxide release. By clearing that out in the atmosphere, you allow for warming to develop. Now you add in CO2 and methane and you enhance it even more. There is some thought, and there's a lot of research going into this, that the amount of cooling that was caused by the sulfur dioxide helped to limit some of the influences. And when we saw that law go in effect, that's when we started to see this escalation to global warming. It can be pretty tricky to nail down every factor. And the atmosphere, as always, never acts like A plus B equals C. There's always a lot of factors that you have to consider. But as always, if we want to simplify this, because I understand a lot of you guys, you didn't take multivariable calculus, you didn't take dynamic meteorology, and me breaking out a chart and saying, oh, if you don't understand this, you're an idiot. Look, it took me 4 years of college, years of studying to understand this. So if you don't understand it right this second, that's nothing on you. I mean, it's hard to understand sometimes. With that said, I'll give you a very simple rule. When you put something into a system, you will get a result out. For every action, there's an equal and opposite reaction. basic stuff. When you add a component in the atmosphere, you will get a reaction. When you take it out of the atmosphere, you're going to get a reaction. So when you're taking sulfur dioxide, you'll get a reaction, cooling. When you add more CO2 and more methane, you get a reaction, warming. That's just the nature of atmospheric systems, almost any system. That's physics, basic physics. So that's what we're seeing here in that event. Let's see. The GFS 18Z for once not spinning up a monster hurricane 14, 15 days out. I'll just give it to the next run. It'll do so. It seems the models have difficulty dealing with urban heat island effect and the impacts on mesoscale events. Oh, absolutely. Absolutely. And they always will, because there's a lot of chaos involved in this. There's a lot of volatility involved in this. From everything from as simple as, hey, when are we having sporting events? How much heat is that putting out? Is this happening during the busiest time of travel? Rush hour, right? So that's a lot more heat added into the atmosphere. What is the surrounding air mass involved in this? Are there other boundaries to act on? Is there a sea breeze front? So is there a moisture gradient like we have now? Okay. How much of a moisture gradient is there? And will the urban heat island effect simply just add to the synoptic gradient? Or does it stand alone and set up a totally different environment? All of these things you kind of have to work out for each event. And you really can't create a locked-in rule. Each event, you have to look at it and say, okay, this is the new environment. Here's what we know. Here's what we're seeing. And here's how the thunderstorms are starting to react. Now go. With that, that's why I always get a good chuckle when everyone is all excited about the AI models. I'm starting to use them. They're a good tool. They're okay. But it's only a tool. Okay? So there's that factor too. Gotta love it. Before Doppler radar was the only radar way to look for potential tornadoes done by looking at hook signatures? Yeah, pretty much. And observations. That's pretty much it. Will the positive QBO, because of the lack of sustained high latitude blocking, enable air masses to move west to east faster? And if so, will that help lessen the impact of Western Atlantic Ridge by throwing more air masses into it? Not in the summer. See, in the summer, the QBO has some influence, but it's not that strong because the polar jet stream is lifted northward. And when you're studying the Western Atlantic Ridge, what you want to do is study the state of the end snow environment and also the Atlantic environment, i.e. all that warm water and where is the cool water pooling. You combine that with the nature of the stratosphere where it's cooler, okay, so it's going to enhance the 500 millibar heights. When you have the QBO, the influence is more on the nature of the polar jet stream being pretty progressive. And typically what you have when you're starting to support more above normal heights and ridges in the mid-latitudes, the polar jet stream generally rides over that, and every so often you get a weakness in between. You can get some more influence in the Pacific, but some of that is more directly connected to more of the typhoons that lift up to the east of Japan. So I wouldn't trust that. The QBO matters more to me, and the evolution of the QBO matters more to me when we start getting into the fall and winter, because that's when we start to really set up our high latitude blocking regimes and really start to feel the influence of the polar vortex. Right now, the polar vortex is pretty much kaput in the troposphere. But the reason why I'm keeping an eye on it is that when you have a QBO in the west, in the westerly position, it basically makes it very difficult for things like a negative NAO to be sustained. It can still develop, and it can be quite strong. It just isn't sustained. And so when we go into the fall and winter months, what happens and what you'll see is the model guides go absolutely nuts about a negative NAO or a negative EPO or a big ridge on the west coast or a big ridge over Greenland and a trough over the Canadian Maritimes. Then once you get about 5 days out, it starts to back off on that. Why? Well, because the jet stream coupled in the polar jet stream is a little bit stronger than expected. And the block that's trying to develop, well, that gets pushed to the east a little bit faster. Kind of throws everything off. The wavelength gets thrown off, and before you know it, you end up with a neutral NAO or a very, very weak negative NAO that falls apart very quickly. So when you have a positive QBO, it makes it more difficult to sustain high latitude blocking. Now, in winters where we had very impressive winter storms with a positive QBO, what happened was the timing was just right. And sometimes, in some winters, you're going to end up with a pattern where the timing keeps on falling in just right, right? It's rare. It can happen. So you never put out rules in meteorology where this can't happen. You have to always be aware of Joker's Wild. Okay? As long as it doesn't break the law of thermodynamics and the law and just basic physics laws, you always have to be aware of the unexpected. Paul asks, you have mentioned a weakness up the East Coast this year due to the Atlantic Ridge and the trough to the west. Was that setup we had with Sandy? What are the chances something like that happened this year? Not the same environment, but I can understand the concern. Typically, in this type of pattern, I'm more concerned about remnant low pressure systems getting drawn up the coast and after they make landfall on the Gulf Coast. Okay, Sandy, the event like Sandy, a lot of people always bring up Sandy. Understand this setup for Sandy, I don't think I'll ever see again in my lifetime. At least I hope. The reason why is because the way that Sandy developed was so incredibly unique, okay? Literally, you had a hurricane that was starting to go through some transitions, that was on its way out, ran into a block in the northern Atlantic, got hooked on, like as if the upper level low was fishing, hooked on, and then pulled it back into the coast and made a landfall right into the Jersey Shore. That very rarely happens. And in fact, I don't remember any other scenario where that happened exactly like that. So you could still have a trough around the Tennessee River Valley, and that doesn't necessarily mean you're going to end up with a type of scenario like what you had with Sandy. What that could lead to is perhaps a tropical low transitioning into an extratropical low lifting up the coast, or a scenario like Hurricane Gloria, where it comes close, skirts, and then heads out. So there's a lot of different events. Sandy was such a unique event that I would not draw comparisons to in any pattern until I literally see it right in front of me. That's how unique it was. And I think in order to respect the unique and dangerous and severe nature of that storm, and to not hype things heading into the tropical season, I think it's best to stay away from that example until we actually are dealing with that type of example, which I would think would be very difficult to pull off. Do you see temperatures this summer having the opportunity to hit 100 plus degree mark? I can't rule it out, but I think this summer is going to be more about the humidity than the high temperatures. Here's what I'm going to be watching for. If we see a large ridge developing in the plains and extending out east, that's when we got to get ready for 100 degree temperatures. If we see the Western Atlantic Ridge build into the East Coast, which I think we're going to see a lot this summer, that's when we're going to be dealing more with like 89 with a dew point in the 70s, and it just feels yucky out. It's just like, ugh, that type of thing. The perfect storm in 1993 ran into a strong block, but the setup, if I recall, was different and kept the bulk of the storm out to sea. It just backed up towards the coast, creating persistent onshore flow. Yeah, and that was an extremely unique scenario. And even in that scenario, it wasn't anything like what we saw with Sandy, but it's still a very impressive storm. And it's a perfect example of what happens when you have a tropical system and an extratropical system interact and phase together. And the perfect storm was a unique storm in the fact that it was one of the first few storms that we had the ability to really dive into the observations, which is what made that storm so unique to study. It seems that Floyd, Ida, Irene type events is a bigger concern than another Sandy. Yeah, I would say that. I would also say this. Right now, what you should do to prepare for the season, since we're already in it, A, don't panic. No reason to panic. No reason to get worried yet. Always have bottled water, batteries, a flashlight, food that you can trust, a large bag of peanuts, because I like peanuts, so there you go, and have a plan. If you do all that, you won't have to panic, you'll be prepared, and you'll be much better off. Let's see here. Let's check out.
All over the place, so we're gonna run long and let you get to it.
Holy smokes! I didn't realize that. Look at that! Wow. YouTube is going nuts. And it gets some other places too, right? All right, let's get into it. Let's see here. I'm gonna pick the best ones on YouTube. Let's see what we got. Well, that's right. So we already discussed the tornado threat. Let's see. Even a PBS tornado warning. Let's see here. Things are not showing up on my screen if you're drawing on map.
As far as I know, you weren't drawing.
No, I wasn't drawing. I was just me being Italian. How do you know what weather app do you have? Oh, okay, hold it. Let's see here. Do you know if the NWS did an effective job forecasting these tornadoes and storms? I won't pretend to know because I don't often look. Overall, there was discussions in the local AFD around Baltimore of the concern. SBC was kind of hinting at it, but really wasn't that strong. Overall, I think they did a great job warning, that is for sure. And they've been very impressive. Thank you, Jay, for the little super thing in live. That's pretty cool. But thank you. Do you see any potential for an extreme summer like 1988, which I recall featured a prolonged Bermuda high and La Nina? 1998 was a special year. I remember that because I was forced to learn how to swim because it was so humid and I had to get into a pool to cool off. I can't say that because that year featured more of a moderate to stronger La Nina than what I'm expecting. But at the same time, the overall atmosphere is a bit different from 1988 because we have higher precipitable water values that we're dealing with. So again, I'd stay away from I can't rule out a period of 100-degree temperatures this summer. I mean, it's silly to try to rule that out at this point. But I certainly like the idea of high humidity and days where we're in the upper 80s and it feels more like the mid 90s. It just feels stuffy. I think we'll see a lot of that. This is a record breaker hot summer for Northeast U.S. I wouldn't jump that. I don't know about that. I don't like forecasting records until they actually happen. I think that's a huge mistake. I think a lot of people do that in my profession. And I think it leads to a lot of conspiracy nonsense that we could really avoid by just not being hyperbolic. The 2010-11 winter had a westerly QBO. Yes, that winter featured something really cool, right? Where the pattern would come together, hit 1 to 3 storms really fast, and then collapse, and then redevelop again, and then collapse, and redevelop again. That was a fun winter, okay? For me, forecasting, it was a blast. But it wasn't always sustained. You had like this development and then breakdown, development and breakdown. And trying to pull that off is very, very difficult. Can it happen? Absolutely. I could also win the lottery, but that's also very difficult too. What is a supercell composite and what does it indicate? I'm thinking you're talking about the SPC. Okay, the supercell composites is basically the combination of different features that we look for, like vertical wind shear, moisture transport, instability in the atmosphere. You combine that for the set ingredients that would give you a supercell, and it shows you that potential. What would happen if there was a high Siberian snowpack by a westerly QBO? That'd be pretty interesting. We haven't seen a lot of those, but essentially you would end up with something like what you had in 2010-11, where you have a disruption in the polar vortex, but again, the blocking doesn't exactly... Usually when you have a positive QBO, you have a more robust polar vortex. You have one that is more difficult to get knocked down, so to speak, okay? It can rebound easier. Okay, that doesn't mean it can't get disrupted. I'll put it to you this way. A negative QBO is basically a boxer going into a match with the flu, right? A positive QBO is basically a boxer going into the match and he just got his pre-workout and he's ready to roll. That's the difference. Can the boxer with the flu win? Sure, especially if he's facing Glass Joe. But it's more difficult. Let's see here. Winter 93, 94, 2013, 2014 had a positive QBO, and those winters were brutal for the United States, especially record-breaking snow. Yes, like I said, it can happen, but it's more difficult to happen. Also, those QBOs were around +8, +7. And there has been some research that if you're between -10 and +10 in the QBO intensity, that could still support some high latitude blocking, and you have a little bit better potential. So there's that to watch out for too. What quadrant of a hurricane is the most likely for tornado formation and why? First, it depends on the coastline, right? So let's say that we're talking about the Gulf Coast. The northeast side of the hurricane is where you're most likely to see those tornadoes. If you're on the Florida Panhandle and the storm is running parallel, it's going to be on the east side. If you have a hurricane going right into Florida, let's say like Andrew, then it's going to be on the north and the northwest side of the quadrant. So it just kind of depends on the track of the storm and the orientation on the coast. Can climate change, global warming be reversed by us?
If we stop being us.
Yeah, right. Okay. That's a bit of a loaded... All right, so, okay. If we've reduced our CO2 input, okay, not completely, because that's just unrealistic. Because everyone's using computers now. How the hell are you going to do that with manufacturing? But let's say we reduce it. Okay, and we go more nuclear, we got wind, we got solar, we cut down the natural gas, we get rid of the coal, blah, blah, blah. Or my hope, we get fusion energy, in which we don't need any of that stuff. We got unlimited energy. So let's go with that, right? If you do that, the Earth is not ending. This idea, save the Earth is fine. We have to save ourselves. The Earth is going to go on just fine. Whether it warms up or cools down, it's still going to be here until the sun reaches the next stage in its evolution in about 1 billion years. So the Earth is going to be fine. We may not. Okay? So there's that aspect. So if we reduce our CO2 and kind of chill out with the input, even by a little bit of reduction, again, let's not go with the pipe dream of zero, okay? Because that just sounds a bit unrealistic to me. Just knowing mankind, okay? The Earth will find a way to balance itself and heal itself. We just have to get out of its way.
You sound like George Carlin. Like you said something very close to what you're saying.
Well, it's true. The Earth is going to be fine. The Earth isn't going anywhere.
That's what he said.
You know. Do you think there'll be tornadoes for Hunterdon County? Not likely. Too far northeast, far too stable. Let's see here. See if there's anything back here in the premium chat. And let's see here. Yes, a radio as well. That's a good idea. Always have a radio as well. Yes, we know the Yankees are all hitting home runs. This is going to be a tough summer for me as a Mets fan. My Mets team can't. Well, they won this past week, but I have the Yankees and a whole family of Yankee fans, by the way. Fun. And I have the Phillies. And it's just, oh, no. Every person and mammal exhales CO2 every time it breathes. Yeah, all right, card. Yes, that's true. CO2 isn't necessarily a pollutant. I think that's a bad idea labeling that. What you just described, like every mammal and plants and what, yes, there's a carbon cycle. Absolutely. You're absolutely right. We breathe out CO2, plants feed on CO2. The issue is that cars, our energy infrastructure, again, I'm not against CO2. Look, we wouldn't have everything we have without CO2, without carbon, forget carbon, without all the energy, all the advancements. And it's silly to like go back and say, how dare you burn oil? Like, please, you like going on your plane too, and you love your Amazon stuff, so save it. But that doesn't mean we ignore the enhancement to the carbon cycle. What you're describing, Card, is the basics of the carbon cycle, in which I agree with you. Every person, every mammal exhales CO2 every time it breathes. Absolutely. And every plant takes in CO2. The problem is not that that process has stopped or ever stopped. The problem is that we're overwhelming that process with a combination of we're cutting down trees. We're cutting down the damn Amazon. That's a problem, right? And we're building. Okay? So you're adding more CO2. There are ways to solve that and still not like destroy the economy and whatnot, or call CO2 a pollutant. That's a ridiculous thing too. But there are ways to do this smartly. Do we have any questions on X?
Oh, glad you asked.
Uh-oh. Oh, boy. It's going to be a busy night on X. And look, we're almost... Holy
Actually,
smokes.
It's one person, but it's like two. So it's long.
Okay. Okay, this is from CTG Cement. Okay, thank you. How are you doing, Steve? I'm doing good. Susan, how are you doing? Just a quick question about an NWS thing I'm not clear on. I know hindsight is 2020, but with this tornado outbreak, not even sure if you'd call it that, for around here, it's close. Would have warranted a severe thunderstorm watch or even a tornado watch. Thanks for all the great work. Big fan. I appreciate the question. I'm not going to say I thought that we'd see this many tornadoes. Should a watch have been issued? Really, the environment was very marginal and focused on a very small area. I do think that, especially around urban areas in the northern Mid-Atlantic, that warning for these events is becoming more difficult because we're changing the microscale and the mesoscale environments involved. So the trigger for these storms is becoming far more difficult to pinpoint. You don't see these issues in the plains. In the plains, it's as clear as day. In the northern mid-Atlantic and the southern mid-Atlantic, you have a clash of literally 6 different air masses, even in this environment, because you have the maritime air mass, you have the urban heat island effect air mass that's modifying that stable air mass, then you have the tropical air mass, then you have the Pacific air mass. So you have a combination of these air masses, they're all clashing. I think that's why we're having a more difficult time putting in those watches. I think that's what happened. And the next question is, also, why do some sneaky marginal risks like today produce pretty potent storms? Although tornadoes were unlikely unless there was a slight risk, I guess this tropic-like setup was surprisingly potent. Again, that all goes back to the urban heat island effect. And I've been noticing this as well, not only with storms up here as well. Look, I've had a hard time forecasting for these type of events because the trigger is so fine. In this environment, it's not screaming tornadoes. Like all the basic rules that we use, this is not screaming tornadoes. This is an environment that's screaming multiple severe thunderstorms. So what you had was the divergence and diffluence setting up over Maryland, just to the northwest of Baltimore and Washington, where you had that urban heat island effect setting up with that gradient. So you had the lifting aloft, lifting at the surface, winds coming from the south of the surface, southwest aloft, so you had that vertical wind shear alignment just right. But once those storms moved away from that alignment, now they're rapidly weakening. And they're starting to lose that punch. Now, once these storms push onto and to the north of that warm front, this whole environment's going to crash. Looking back on it, would you have issued a severe thunderstorm or tornado watch? It wouldn't be for the whole region. It'd be a very, very small slither of the region that would set that up. It's difficult it's difficult for me to criticize because I don't think I could have done a better job, to be honest with you. I think they did an excellent job with sending out warnings, getting people. The media down there has done an amazing job. The storm chasers down there have done an amazing job. I can't criticize watches because you know what? I don't think I would have done any better in this environment. Because if I was looking at this in the morning, the last thing I was going to be worried about was tornadoes. Heavy rainfall, sure. Downburst wind gusts, absolutely. Vivid lightning, yeah, absolutely, especially with high precipitable water values. Tornadoes, especially the ones we've seen on social media, no, I wouldn't have been able to do that this morning. No. So it's not for me to criticize because I don't think I would have done a better job.
Just a side note.
Yeah.
Somebody on Facebook had asked if you were drinking a pounder beer. I corrected them that no, it's just water.
Liquid death, water. I know it looks like, I'm just waiting for, because sometimes I drink these when I'm in the car. I'm waiting for a cop to pull me over and say, you're driving with an open container. Like, it's just water.
Liquid death, mountain water.
Yeah. It stays colder. I like it, It helps my throat, too, when I'm talking for over an hour. Let's see here. I think we had pretty good questions out here. If you want to see urban heat island, compare temperature in Philly and those northwest Doylestown. On most days, you see the difference. Same between Newark and... Yes, exactly. And I'll tell you this. Watch this summer, guys. If you're around Newark and just to the northwest of Newark, and if you're just to the northwest of Philadelphia, watch the development of these thunderstorms as they approach. They'll weaken a little bit and then rapidly intensify, run into the gradient, and then weaken again. Watch that, especially around Newark, for a impressive heavy rainfall event set up this summer. Just keep an eye on that. I think you're going to see exactly what I'm talking about. And with that, it's 9 o'clock. Do we have any more questions?
I don't know if I think you might have gotten everything.
Okay.
Give one last look at YouTube.
Let me take a look at YouTube, and then I think we're good. All right. So this has been a very fun night. I hope you guys have learned a lot. We went over the severe thunderstorms. We answered your questions. So with that, we're going to close it off for tonight. Watch out for the heavy rainfall that's going to be lifting through. Probably going to hear basically a very heavy rainfall and probably some rumbles of thunder as well overnight tonight, especially around midnight around the area. Should clear out pretty nicely tomorrow morning. Morning rush hour, a little bit hit and miss around New York City Metro and around Connecticut with some of that heavier rainfall. But Philadelphia, you'll clear out just fine and be fine. That's it for tonight. Thank you again for joining. I really appreciate it. And as always, stay safe out there.